Hello and welcome to Automation Fair 2012 in Philadelphia. I'm Teresa Hauk, Executive Editor of the Journal from Rockwell Automation and our Partners Magazine. This is where the best companies in industrial automation are showing off their wares, and one of those best companies is Littelfuse. I'm talking with Tony. Tony, tell us what you guys are highlighting this week.
Yeah, well, thank you, Teresa. We're highlighting our arc flash relay. Basically, in the most simplistic form, an arc flash relay is a light relay. It's looking for an overabundance of light. When it sees it, it actually takes that signal back into the relay and it processes it, and then it sends out a signal to shut down power. So a great example of that obviously is an arc flash, which emits a tremendous amount of light. So this will detect it, it sends it in here, and it processes it within 1 millisecond. Sends an output out to a circuit breaker to remove power. And again, it's extremely fast when it does that. Now, to prevent against nuisance tripping, if somebody, for example, opens a door and sunlight were to hit these fiber optics or something like that to happen, the user has the ability to validate this signal against current. So if for some reason there's an over light condition, and then it sees it and it says, wait a minute, let me see if there's an overcurrent condition. If there is that as well, it says it must be an arc flash, then that's when it sends a signal to the circuit breaker to remove power. Now, there are a couple of features here I want to highlight, because an arc flash relay, it has the ability to lower your PPE. So if it does that, it must be highly reliable, have several different redundant features to it, and be easy to use. So a couple of different things I want to highlight here is, as you can see here, the sensors are blinking twice. That means they're active. If for some reason one sensor were to fail, and I'll simulate that by switching that switcher, you can see there's no longer blinking. And after a period of time delay here, the relay sees that the sensor is not wired properly, something is wrong. So it alerts the user to come out and repair the sensor, or it also prevents a user from working in that cabinet because he's not protected. And other possibilities here, so with the relay here, it sees the light, it sees the overcurrent, sends out a signal, and if for some reason that this circuit breaker the wiring isn't correctly, the trip coil wiring, for example, say it's broken or becomes loose, the circuit, or the relay rather, will see that condition and send an alarm out to the user saying, look, we see their light sensors are working properly. However, if I see an arc flash, I cannot trip because I'm not wired correctly to this circuit breaker here. Now, I'll go ahead and put that back in the same condition here. And every input and output going into the relay is monitored the same way that the sensor and the trip coil is monitored. So if for some reason that if any input or output, wire comes loose out to the CTs, it will create an alarm condition. So the user can come out and repair the problem there. And I'll go ahead and demonstrate here. Give me a second here for this flash here to charge up. It also has the ability to, it takes control power coming into it. It actually recharges a rechargeable battery to normal operation. So if you were to lose power, it now gets its power from the batteries. So again, another reliability feature there. And now I'll demonstrate, so this will simulate an arc flash incident here. So as you can see here, it saw the light. All four sensors, 1, 2, 3, and 4, saw the light. The signal went into the relay, it saw the condition, and it sent an output up to the circuit breaker, and you can see it trip now.
Now, what happens if it doesn't trip?
That's a great question. So if it doesn't trip, this actually has the ability, that's not shown here, but to trip an upstream breaker. So we look for that as well. So for some reason we see an arc flash, and it creates a signal, it goes to the local circuit breaker to trip, it doesn't trip, it sends a second signal up to an upstream breaker to remove power. So again, it's an extra redundant feature built into the relay there. And you can also see here the sensors are blinking at a different rate. They're not blinking twice, two quick blinks to say that the system is okay. It's blinking one slow one. That tells you which sensor saw the fault there.
Now I see two different kinds of sensors. What's the difference? How would someone choose which sensor to use?
So there's two different options. We call this our point sensor. This basically is looking just one direction for about 10 feet out, about 6 feet diameter, about 10 feet out, sort of a cone shape. This is good for open space. So you may have a transformer compartment, a primary, secondary you can put inside there, or a bigger compartment, a VFD compartment, something like that. That's where these are mostly used. If you run into a motor control center where the buckets are very small, and you would have to have one of these for each bucket, may not be practical, you can take this fiber optic here, and this is actually 25 feet in length. It actually goes continuous into here, but for demonstration purposes, it's bundled in the back there. You can take 25 feet of this fiber, and you can string it along all the buckets. And so you get greater coverage this way by doing it that. The only downfall of that is you don't know exactly which bucket had the arc flash, because anywhere along this fiber, that's where it sees the arc flash, and it would then channel that signal back into the relay here. So it depends. If you have a bunch of tight, small compartments, you would probably use a fiber optic to be strung through them. If you have a big open compartment, you'd use a point sensor there.
Well, there's so much more to learn about the Littelfuse product, so visit the website at rockwellautomation.com/go/P-Littelfuse. I'm Teresa Hauk at Automation Fair 2012. We'll see you next time.